we're back and running. I'll just run through this. What we're looking at with this problem in part 2, initially the first thing is to use the product rule. That's where we've got a function that is two functions multiplied by each other, like this one here. So we've got 3x squared times sine 2x. We say we're going to let u equal the first function and let v equal the second function. We then differentiate those two functions. So this function differentiated, Jordan, is, yeah, just what the answer is, 6x. So we brought that down and multiplied. 2 times 3 is 6. Took 1 off the index. And dv by dx, Caleb, is 2 cos 2x. So everyone agree with that. Yeah. What we then do is place each of those items in the formula for dy by dx of a product rule, which is u dv by dx plus v du by dx. U we set to 3x squared. I'm going to multiply that by dv by dx, which is 2 cos 2x, and then add on v, which was sine 2x times du by dx, which is 6x. Yeah. Now, if we look at the possibility of simplifying that, there's a pair of brackets there multiplied together. So we could do, could we not, 3x squared times 2, 6x squared cos 2x. Is that bit simplified? Because what this bit is here is just 2 times the cos of 2x. We can multiply that by 3x and end up with that there. And plus, and this bit is just 6x sine 2x. Just get rid of the brackets. Where's the common term in there now? 6x. So that means we can take 6x outside a set of brackets. What do I put inside the brackets? X cos 2x plus sine 2x. Okay. Now, if there's a longer question like this, or a question with more marks like this, it might well say in its simplest form, but you're going to get some marks if you get to that or that and don't get all the way to the final bit. Okay. So there might well be, could be a question that asks for the answer in its simplest form, which would be that form. All right, but you're going to get marks for getting to this stage, or indeed that stage, because they're both right answers in essence. And if you want to find the value of that differential at a particular value of x, any of them are going to give you the right answer if you plug the right numbers in. Okay. So you're all happy with that one as as initial introduction to the method of using the product rule. Some, if not all, have started this one. This one says determine the rate of change of voltage given V is equal to 5t sine 2t So we got a function of t and another function of t. We've got a function multiplied by another function. But we've got to find dv by dt, the rate of change of voltage with time when t is equal to 0.2. So we need to differentiate, then evaluate at t is equal to 0.2. 5t, not 15t. Ah, that was me. I've shown the two functions. Let me do it again. 5t sine, yeah, I'll do it another colour. 2t. And what I said was that was one function, and there's the other function. Sorry about that. Okay. So what are we going to let u equal? V equals sine 2t. Du by dx, 5, t disappears. Yeah. dv by dx, t cos 2t. Yeah. So then we put that into the full formula with the v by dt here, and all of these should have been dt, by the way, because our independent variable in this particular example is t, not x. Yeah, yeah, 1 mark for over the whole question. Right, you've got to use the right independent variable. U 5t times 2 cos 2t plus sine 2t times 5. Can you simplify that or not? Let's simplify one side first. Multiply them brackets out. 10t, innit? 2 times 5. Agreed? Common factor is, if you want a common factor, 5, innit? So you could take 5 outside the brackets. 2t cos 2t plus sine 2t. What the question then wants to do is say when t is equal to 0.2, dv by dt is equal to 5 times 2 times 0.2 cos 2 times 0.2 plus sine 2 times 0.2. Plug in. Five times 2t gets me back to 10t. Final answer for the video. You plug the numbers in like that. Remember, calculator must be in radians, and we get an answer. The rate of change of voltage when t is 0.2 seconds, 3.96 volts. Sorry? Sorry? Don't remember, I will look. Okay. Is volts right? Have I given the right units there? Rate of change should be volts per second. So what that's saying is the voltage is increasing at that point by 3.79 volts every second. Right, so that's the product rule. I've brought out a few questions from the third book at the end of the thing that you can have a go at to practice the product rule. And we'll be doing some more stuff for that next week anyway. Quotient rule. So along the similar lines here, we've got a fraction where y is equal to 4 sine 5x over 5x power of 4. One function divided by second function. A quotient. Use a mathematical term. With the quotient rule, we must be very careful to get the items round the right way, because we're subtracting. Alright, we must call the numerator u. So let u equal 4 sine 5x. And the denominator equal v. Then differentiate them, plug them into this formula here, and perhaps simplify. So have a go, see if you can do that. Right, gents, du by dx is equal to what do we do? (20 cos 5x). Everyone agree with that? Yep. dv by dx. Yeah. So that's 4 times 5 is 20. X to the 3. Yep. And what we got to do, plug it into the formula. If you tell me what to write, I'll write it. dy by dx is equal to 5x to the power 4. That's v. Times 20 times 5x. That's the du by dx. minus 4 sine 5x times 20x cubed all over b squared. And b was 5x to the 4. What's the rule of indices on 5x to the 4? Squared. We've got a number raised to a power. Raise it to another power. So what is that simplified then? So you're saying that is equal to 5x to the 8. Yep. Right. Set a value for x, 2, and put that in your calculator with x equal 2, and that in your calculator with x equal 2. Are they the same? You missed a bit, Lewis. What that is 5 squared times x to the 4 squared. So you've got to square the constant as well. So the answer to that simplified is 25x to the 8. Yeah. Two times 4 is 8. So that bit under there simplifies to 25x to the 8. Yeah. So let's have how can we simplify the top line? What can we do multiplying these two out? Hang on, don't do any more yet. We've still got to put our 25x to the 8 underneath. Don't forget that. Yep. Does everybody understand what's happened there? Multiplied out these two brackets. 20 times 5x to the 4 is 100x to the 4. Leave the cos 5x bit as it is. 20 times minus 4 is minus 80 x to the 3 sine 5x stays the same. Everyone happy with that? Yep. Or not? Can we further simplify the top line? No. What's the biggest common factor of 80 and 100? Yep. 20x cubed. on the outer side of the brackets. What have I got to multiply 20x cubed by to get back to 100x to the 4th? 5x. Because 5x minus, what have I got to multiply 20x cubed by to end up with minus 80x cubed? 4 sine 5x. Close the bracket. All over 25 x to the 8. Okay. I wouldn't expect you to go any further and do anything other than that. All right. And actually, this is a correct answer to it. You'd get some marks for getting to there, and I'd take full marks for that one, if that was all I was asking you to do. All right. Any further questions on that? Right. On the next page, there's another quotient rule for you to have a go at and determine the gradient at the point where x is equal to root 3 and y is equal to root 3 over 2. So just see if you can differentiate it first using the product rule. I'll go back and sum up that last one on the video because I ain't done that yet. Sad. What we'll do is go through it, I think. So you need to let u equal 5x because that's the numerator. V equal 2x squared plus 4. Differentiating each of those, so the differential of 5x is five. Differential of 2x squared plus 4 comes out as 4x. Constant disappears. Okay. We then plug those into our formula. So we need v first. 2x squared plus 4. We're going to multiply that by du by dx, which is 5. Take away u, 5x, multiplied by dv by dx, 4x. All of that divided by v squared. So 2x squared plus 4 all squared. In this case, the argument, if you multiply that out, you're just making it more messy. Leave that as it is. Nice and tidy like that. Okay? So what we can do is simplify the top line. So underneath, keep 2x squared plus 4 all squared. Top line becomes 10x squared plus 20 minus 20 x squared. Yeah. Any further simplification of that? Well, you've got two 2x squared terms in there. Yeah, so you could actually do 20 minus 10x squared all over 2x squared plus 4 squared. Ultimately, if you plug what the question's asking for, x is equal to the square root of 3, into this one or that one, if you got it right, you should get the same answer. So we should be saying when x is equal to the square root of 3, dy by dx is equal to 20 minus 10 times root 3 squared, all over 2 times root 3 squared plus 4 all squared. Equals minus 0.1 equals minus a tenth. So either of those is the right answer. Gone wrong somewhere then. Probably in how you've used the calculator here with the brackets. I mean, what is the square of root 3? 3. So that top line is 20 minus 30. Why? Well, you multiplied out that bracket and ended up with just 4. You've probably done, well, you've definitely done the wrong thing. Yeah. There was no need to pull that about, because that's simple as you're going to get it. Yeah. Because as soon as you multiply that out, you've got a term 2x squared times 2x squared as 4x to the 4. You're just making it plus 16x squared plus 16, and that ain't helping you. All right? Yeah. So just be careful about that. Going down dead ends. Right. Last little bit I want to cover today is the function of a function rule. All right. What we've got here is y is equal to 3 cos 5x squared plus 2. This bit in here is a function. Right? And then the cosine, or 3 times the cosine, colour. The cosine with its brackets is another function. So the cosine is doing a function on the function that is 5x squared plus 2. It's a function of a function. Yeah. You're going to use what's called the chain rule for this. Well, and I'm going to go through this first one with you step by step. So, what we do here is let u equal 5x squared plus 2. The bit inside the cosine function. What that means is This means that we can write and I'll do it in a different colour, y is equal to 3 cos u. Yep. So we called the bit inside the cosine brackets an arbitrary letter, usually u. It don't really matter which one you pick, but by convention it's u. Okay. And so then we can redefine the function as y is equal to the other function with that function replaced, in this case 3 cos u. Then differentiate. So we differentiate this. So what to find the y by independent variable here is hang. dy by du is, going to differentiate this one first. Why is u coming outside? Is there an a in there? Remember, what we've done is we've changed the independent variable here to u. We also need to find, as you rightly say, the du by dx. X, that's differentiating that one. Okay, then we plug those into the formula for the product rule. So what we can do now is say dy by dx is equal to, and looking at the formula, it is dy by du minus 3 sine u, yeah, multiplied by du by dx, which is 10x. Multiply those brackets out. (10x) times minus 3 is minus 30 x sine u. What we then do is replace u with original function, what it was equal to. So the final answer is that dy by dx is equal to minus 30x sine of whatever we called u in the first place, which was 5x squared plus 2. So what we've effectively done is made a substitution of an arbitrary variable for the function that sits inside another function. So if you had something like this, 2x squared plus 3 all squared, that's a function of a function. we've got a function inside the brackets, and we're squaring it outside. So that you do function of a function on that. On the next page, there is another example. How could we rewrite? What we've got is y is equal to the square root of 3x squared plus 4x minus 1. How could we rewrite that better for differentiation? No, don't you're differentiating what's inside it. Yeah, you've got to do all of that. Remember that root sign over there implies there's brackets round whatever is inside it. Yeah. So there's our brackets. There's our 3x squared plus 4x minus 1. Close the brackets, and how do we make it a square root? We raise it to the power of a half. So there's one function, and the function being applied to that function is a square root. Yep. So what are we going to let u equal here? Yep. Let u equal the function inside, and so on. Right. So for the sake of the video, went through, set u equal to the function inside the brackets, differentiated to find du by dx and dy by du, brought that together in the formula, simplified and replaced u in the final version. Okay.